It does feel like math and physics are both sneaking up to a deep truth from slightly different angles, and you stand at the crossroads or at the intersection of the two. It's interesting to ask, what do you think is the difference between physics and mathematics in the way physics and mathematics look at the world?
There is actually an essential difference, which is that physicists are interested in describing this universe. Okay, mathematicians are interested in describing all possible mathematical universes, of which, and some of our work, I still consider myself more of a mathematician than a physicist. My first love for physics notwithstanding. Mathematicians are, in a way, we have more diversity, if you might say. So we are accepting, for instance, our universe has three spatial dimensions and one time dimension, right? So what I mean is that
Allegedly,
observed, but that we can observe today, yes. Right? So of course there are theories where there are some hidden dimensions as well. Well, let's just say observed dimensions. So this tabletop has two dimensions because you can have two axes, two coordinate axes, x and y, but then there is also a third one to describe the space of this room. And then there's a time dimension. So realistic theories of physics have to be about spaces of three dimensions, or space-times of 4 dimensions. But mathematically, we are just as interested in theories in 10 space-time dimensions, or 11, or 25, or whatever, or infinite dimensional spaces, So that's the difference. On the other hand, I have to give it to the physicists. We don't have the same satisfaction that they have of having their theories confirmed by an experiment. We don't get to play with big machines like LHC in Geneva, a Large Hadron Collider that recently discovered, the Higgs boson and some other things. For us, it's all like a mental exercise in some sense. We prove things by using rules of logic. And that's our way of confirming, experimental confirmation, if you will. But I think I kind of envy a little bit my friends physicists that they get to experience this sort of these big toys, and play with them.
But it does seem that sometimes, as you've spoken about, abstract mathematical concepts map to reality, and it seems to happen quite a bit.
That's right. So the mathematics underpins physics. Obviously, it's a language. The book of nature, as Galileo famously said, is written in the language of mathematics, and the letters in it are the circles, triangles, and squares. And those who don't know the language, I'm paraphrasing, are left to wander in a dark labyrinth. That's a famous quote from Galileo, which is very true and has become even more true more recently in theoretical physics, in the most sort of far out parts of the theoretical physics that have to do with elementary particles and as well as the structure of the cosmos at the large scale.
What do you think of Max Tegmark, who wrote the book Mathematical Universe? Mm-hmm. So do you think, just lingering on that point, you think at the end of the day, the future generations will all be mathematicians? Meaning the ones that deeply understand the way the universe works. At the core, is it just mathematics?
At the core of, I would say mathematics is one half of the core. Mm-hmm. So the book is called Love and Math.
Yeah.
Okay, so these are the two pillars, if you will.
Yeah.
In my view.
Yes.
In other words, you can't cover everything by math. So mathematics gives you tools. It gives you kind of a clear vision. But mathematics by itself is not enough for one to have a harmonious and balanced life. So I am suspicious of any theory that declares that everything is mathematics.
So math can generate things that are beautiful, but it can't explain why is beautiful.
Math, you could say, is a way to discern patterns, to find regularities in the universe, and both physical and mental universe. Mathematics explores the mind as much as it explores the physical world around us, and it helps us to find those patterns, which makes our perception more sophisticated, our ability to perceive things such as beauty, and it sharpens our ability to see beauty, to understand beauty. So our world becomes more complex from thinking that Earth is flat. We go to realizing that it is round, that it's shaped as a sphere, so that we can actually travel around the Earth. So there isn't a place where we hit the end, so to speak. And then, proceeding in the same vein, then Einstein's general relativity theory tells us that our space-time is not flat either. This is much harder to imagine, a bent three-dimensional or three-dimensional space or four-dimensional space-time, because this idea that the space around us is flat is so deeply entrenched. And yet we know from this theory and from the experiments that have confirmed it, that a ray of light bends around a star as if being attracted by the force of gravity. But in fact, the force of gravity is the bending. It's just that it's not only the bending of the space, it's also the bending of space-time. There is a curvature, not only between spatial dimensions, the way parallels and meridians come together. In a small scale, they look like perpendicular lines. But if you zoom out, you see that they curving the space. They are sort of the tracks along which the space gets curved. That would be the curvature of spatial dimensions. But in fact, now throw in time, and imagine a sphere which has one of the meridians correspond to time, and the parallels correspond to space. I can't imagine it, but I can write a mathematical formula expressing that curvature, and in fact, that curvature is responsible for the force of gravity, attraction between the sort of simplest instantiation of it, attraction between two planets, or between two human beings, for that matter.
Yeah, bending time, it's not very nice what that theory did to time, because it feels like the marching of time forward is fundamental to our human experience. The arrow of time marching forward nicely seems to be the only way we can understand the universe. And the fact that you can start
up to now, there are people who claim that they possess other ways of experiencing it.
So truly can visualize messing with time.
Well, messing with time, but not necessarily messing with time, because one point of view is that, I think, who was it? I think William Blake, who wrote that eternity loves time production. So one point of view is that it is eternity which is fundamental, where time stands still, which our mind conceptualizes as the time. So, but in fact, it's not something mystical. If you think about when you're really absorbed in something, time does stand still. And then you look at the clock and it's like, oh my God, 2 hours have passed. And it felt like a couple of seconds. When you are absorbed, when you're in love, when you are passionate about something, when you're creating something, we lose ourselves and we lose the sense of time and space, for that matter, you see. So there is only that which is happening, that creative process. So I think that this is familiar to all of us.
And we may be actually the closest to the truth at that moment, to the true nature of reality.
So then there is a point of view that this is where we are. We are who we are at our sort of fundamental level. And after that, the mind comes in and tries to conceptualize it. It's like, oh, because I was writing something. I was writing a book. I was painting this painting. Or maybe I was watching this painting and got totally absorbed in it. Mm-hmm. Or I fell in love with this person. That's what happened. But in the moment when it's happening, you're not thinking about it. You're just there.
Yeah, we construct narratives around the set of memories that
That's
seem to have happened in sequence, or at least that's the way we tell ourselves that. And we also have a bunch of weird human things like consciousness and the experience of free will that we chose
yeah,
a set of actions as the time unrolled forward.
right.
And we are intelligent, conscious agents taking those actions. But what if all of that is just
An illusion.
an illusion and a nice narrative we tell ourselves?
Sure,
That's a really difficult
it's
thing
possible.
to internalize.
And imagine that to make it really catch 22. Imagine that our minds are set up in such a way
Yeah.
that they can't approach the world or experience otherwise. So, in other words, to understand, to see that from a more kind of all-encompassing point of view, we have to step out of the mind.
Mm-hmm. Well, I wonder what's the more honest way to look at things.
But I think we like to play with time. I think we like to play with these experiences, with all the drama of it, with all the memories, with all the tribulations.
Yeah. I think
we love it. We love it. Otherwise, we wouldn't be doing it.
I think or Earth loves it. The evolutionary process somehow loves it.
Sure.
Whatever this thing that's being created here on Earth, it seems to like to allow its children to play with certain truths that they hold, this subjective truths that are useful for the competition or whatever, this dance that we call life, broadly defined,
Absolutely.
not just humans.
And I'm glad you mentioned that, because what I find fascinating is that the greatest scientists are on record saying that when they were making their discoveries, they felt like children. Mm-hmm. So Isaac Newton said, to myself, I only appeared as a child playing on the seashore, and every once in a while finding a prettier pebble or a prettier shell, whilst I think he said something like the infinite ocean of knowledge was lying before me. Alexander Grothendieck, who probably was the greatest mathematician of the second half of the 20th century, the French mathematician, Alexander Grothendieck, wrote that discovery is a privilege of a child. The child who is not afraid to be wrong once again, to look like an idiot, to try this and that, and I'm paraphrasing, and go through trial and error. That is for them, in other words, for them, that innocence of a child who is not afraid, who has not yet been told that it cannot be done, okay? That was essential to scientific pursuit, to scientific discovery. And now also compare it to Pablo Picasso, a great artist, right? So who said every child is an artist. The question is how to preserve that as we grow up.
Do you struggle with that? You're one of the most respected mathematicians in the world. You're Berkeley. You're like this a statue. You're supposed to be very like,
ivory tower. Kind of.
Yeah.
Sometimes I joke. I say I take an elevator to the top of the ivory tower every day. Yeah.
And you're supposed to speak like royalty. Do you struggle to strip all of that away to rediscover the child when you're thinking about problems, when you're teaching, when you're thinking about the world?
Absolutely. I mean, that's part of being human, because when we grow up, I mean, all of these great scientists, I think they were so great in part because they were able, could maintain that connection, okay, and that fascination, that vulnerability, that spontaneity, and kind of looking at the world through the eyes of a child. But it's difficult because, you go through education system, and for many of us, it's not especially helpful for maintaining that connection, that we kind of we're being told certain things that we accept, take for granted, and so on, and little by little. And also we get hit every time we act different, okay? Every time we act in a way that doesn't fit sort of the pattern. Mm-hmm. We get punished by the teachers, get punished by parents, and so on.
And don't get respect when you act childlike in your thinking, when you are fearless and looking like an idiot.
That's right.
Because there's a hierarchy in society.
Nobody wants to look like an idiot, once you start growing up, or you think you're growing up.
Yeah.
In the beginning, you don't even think think in these terms. Mm-hmm. You just play. You're just playing. and you are open to possibilities, to these infinite possibilities that this world presents to us. So how do we? I'm not saying that education system should not be also kind of taming that a little bit. Obviously, the goal is balance, that acquiring knowledge so that we can be more mature and more discerning, more discriminating in terms of our approach to the world, in terms of our connections to the world and people and so on. But how do we do that while also preserving that innocence of a child? And my guess is that there is no formula for this. It is a life is an answer. Every life, every human being is one particular answer to how do we find balance.
That's one imperfect approximate solution to the problem.
But we can look up to the great ones,
yeah,
who have credentials in the sense that they have shown and they have proved that they have done something that other humans appreciate, our civilization appreciates, say Isaac Newton or Alexander Grothendieck or Pablo Picasso. So they have established their right to speak about these matters, and we cannot dismiss them as mere madmen. They say, okay, well, if the same thing was said by somebody who never achieved anything in their field of endeavor, it would be easy for us to dismiss it. But when it comes from someone like Isaac Newton, we take notice. So I think that's something important that they teach us, and especially today, in this age of AI. Of course, there's a big elephant in the room always, which is called AI, right? And so I know that you are an expert in the subject, and we're living now in these very interesting times of new AI systems coming online pretty much every couple of weeks. So I kind of, to me, that whole debate about what is artificial intelligence, where is it going, what should we do about it, needs an influx of this type of considerations that we've just been talking about. That, for instance, the idea that inspiration, creativity doesn't come from accumulation of knowledge, because obviously a child has not yet accumulated knowledge. And yet the great ones are on record saying that a child has a capacity to create. And an adult credits the inner child. For this capacity to create as an adult, you see. That's kind of weird if we take the point of view that everything is computation, everything is accumulation of knowledge, that just bigger and bigger data sets, finer and finer neural networks, and then we will be able to replicate human consciousness. If we take that point of view, then what I just said kind of doesn't fit. Because obviously a child has not been fed any training data, as far as we know. Yet they're perfectly capable of distinguishing between cats and dogs, for instance, and stuff like that. But much more than that, they're also capable of that, wide-eyed, sort of perspective. So can it really be captured? That perspective, that sense of awe, can it really be captured by computation alone? I don't know the answer, so I'm not sort of trying to present a particular point of view. I'm just trying to question any theory that starts out by saying life is this or consciousness is this. Because when you look more closely, you recognize that there are some other things at play which do not quite fit the narrative.
And it's hard to know where they come from. It's also possible that the evolutionary process has created it is computation, and the child is actually not a blank slate, but the result of one of the most incredible several billion year old computations that had explored all kinds of aspects of life on Earth, of war and love and terror and ambition and violence and invention, all of that, from the bacteria to today. So like that young child is not a blank slate. They're actually
They
hold
carry
within them the knowledge of several billions of years.
Right. The question is whether, as a child, you carry that in the form of the kind of computational algorithms that we are aware today. You see, what strikes me as unlikely is that, how should I put it? How interesting that, you are a computer scientist, and there are other people. I have studied computer science, so I know a little bit. And so it's tempting to say, oh, the whole world is computer science, or can be explained by computer science.
Yes.
Why? Because it makes me feel good. Because I have mastered it. I have learned it. My ego is very happy.
Yeah.
And people come to me and they look up to me and they revere me. Kind of like priests in old days when religion was paramount, when you would tend to explain things in theological, religious terms. Today, science has progressed. There are fewer people who kind of buy into religion, official religion, So we have this urge, I suppose, to explain and to know and to dissect and to analyze and to conceptualize, which is a wonderful quality that we have, and we should definitely pursue that. But I find it a little bit unlikely that the universe is just exactly what I have learned and not something that I don't know, you see?
Well, there's a lot of interesting aspects to the current large language models that one perspective of it, I think, speaks to the love and math that you talk to, which is they're trained on the human data from the internet. So at its best, a large language model like GPT-4 captures the magic of the human condition on its full display, its full complexity. It's mimicking, it's trying to compress all the weirdness of humans, of all the debates and discussions, the perspectives, all the different ways that people approach solving different problems, all of that compressed. So we're each individual ants. We only have we have a family, we interact with a few little ants. And here comes AI that's able to summarize like a TLDR report of humanity.
And that's the beauty of it. So I embrace it.
But I wonder if
I'm very impressed by it.
I wonder if it can be very impressive, meaning way more impressive in being able to fake or simulate or emulate a human.
Fake. I'm glad you mentioned that, because that seems to be the mantra.
It's just
fake it till you make it.
Yeah.
Isn't it?
Isn't that what we all do, though?
No. Well, yes, we do that. But we also do other things. We can be truly in love. We can be truly inspired when it is not fake. I do believe. Call me romantic, okay? But I do believe. And this is a very good. I'm glad you're putting it in these terms, because I've had conversations like that. Yeah, fake it till you make it. But that's what humans do. Yes, we do that, but not all the time. So, and that is debatable, because also I speak from my own experience. And that's where the first person perspective comes in, the subjective view. I cannot prove to you, for instance, or anyone else, that there are certain moments in my life where I am genuine, I am pure, so to speak, when it's not faking it. But I do have a tremendous certainty of it. And that's a subjective certainty. Now, as a scientist, I'm also trained to give more credibility to objective arguments, that, things that can be reproduced, things that I can demonstrate, that I can show. But as I get older,
there we go.
As I get more mature, hopefully, I'm starting to question why I am not giving as much credibility to my subjective understanding of the world, the kind of the first-person perspective, when actually modern science has already sold on that. Quantum mechanics has shown unambiguously that the observer is always involved in the observation. Likewise, Gödel's incompleteness theorems, to me, show how essential is the observer of a mathematical theory. Yeah. For one thing, that's the one who chooses the axioms. Yes. And we can talk about this in more detail. Likewise, Einstein's relativity, where time is relative to the observer, for instance.
That's brilliant. You're just describing in all of these different scales the observer, what the observer
That's
needs.